Okay, we have here today another integral. This one's from the Scranton integration, be 2015, problem 4. We have the integral from 0 to square root of pi, x sine squared x squared dx. Okay, the first thing I notice here is just that we've got x squared here as the input to sine. That's always going to be a problem. We can have a coefficient here in front of the x, but when we have any kind of power on here, it's going to make it difficult. So what I want to do to clean this up is let's just do a u substitution right on the x squared. So I'll say u equals x squared. I'll take a derivative. So for du, we're going to just get 2x dx. But now for the x, we have that right here. I just want to create this 2, so I'll multiply by 2 in front, but in order so that I'm not changing it, we'll just multiply by a half out front. Then we'll just go ahead with this substitution, so we'll have our 1/2. Then when we plug square root of pi in for x squared, our upper bound just becomes pi. We take our 0, we plug that in, we get 0 for the lower bound. Then this part here is going to just transform into sine squared of u, and again our du is going to be this with the dx, so everything else is just du. But then for sine squared u, I can use a power reduction identity on this, and I'll just rewrite this, so we'll have the same bounds. And then for sine squared u, I can write it as 1/2 in front, 1 minus cosine of 2u du, just using a trig identity on that. But then I think I'll take this 1/2 out front and combine it, multiplying times this other 1/2, this is going to become a 1/4. And then we can just go ahead and integrate this. So we'll have our 1/4 in front. Integrating 1, we get u. Then next, integrating cosine 2u, this is going to give me sine 2u, but I need to bring the 2 out front in the denominator as 1/2. And we just need to evaluate this from 0 to pi. So now we'll go ahead, we'll plug everything in. We'll keep our 1/4 out front of everything. Then plugging in pi, so we're going to have here, it's going to be pi minus. Now when you plug pi in here, you'll have sine 2 pi, but sine of 2 pi is 0, so this piece will just have a 0 here. Then for the second part, we'll plug in 0. This is going to give me 0 minus sine at 0, again, that's going to be a 0. So this whole part here is just gone. And so we just need to multiply up 1/4 times pi. So for my final solution, we get just pi over 4. Okay, there you have it. Quick integral from Scranton 2015. Thanks everyone for watching. Have a good day.